Hey guys, today we're going to be working with graphing radicals. Radicals are really easy to graph as long as you have a basic understanding of what perfect radicals are. So if you don't, look up perfect roots and try and get some basic understanding before we try graphing. But if you can make an XY chart, I promise you can graph a radical function.
Let's explore some more difficult problems. So we're going to take this equation, which has an a, h, and k value, and we're going to try and figure out how to graph this one. So again, the first thing we want to determine, is it even or odd? Square roots are always even, which means my shape is going to have an endpoint and then go up or down from there. So we know that it's going to have an endpoint, which is important. So the first thing we want to find for even radicals is to find that endpoint. So we take what's inside the parenthesis that's inside the radical, and we set that equal to 0 and we solve. So add 2 to both sides. So the x value for our endpoint is going to be 2. We put it in the top because that's our endpoint, so everything is determined off of this starting point. And then I plug that in, so it's 2, 2 minus 2 plus 1. And then I just do order of operations. So radicals we treat like parentheses. We simplify that first. 2 minus 2 is 0. So I'm going to have 2 times the square root of 0 plus 1. Square root of 0 is 0. So this is going to become 2 times 0 plus 1. 2 times 0 is 0. Plus 1 is 1. So this is 2, 1. Then I'm going to pick other values that are going to be perfect square roots. So if I pick 3, 3 minus 2 is 1, and I know 1 is a perfect square root. And if I pick 6, 6 minus 2 is 4, and I know that 4 is a perfect square root. If you don't pick perfect numbers, then you're just going to end up working with decimals. So I do 3 minus 2, which is 1. The square root of 1 is 1, so I'm going to skip to that step. So again, 3 minus 2 is 1, and then I square rooted it and got 1. And then I multiply it by the outside, so 2 times 1 is 2, 2 plus 1 is 3. This last one here, I'm going to plug in 6, so it's going to be 2 rad 6 minus 2 plus 1, 2 times rad 4, square root of 4 is 2, plus 1, 2 times 2 is 4, 4 plus 1 is 5. So I'm going to go and plot these points, 2, 1, 3, 3, 6, 5. So I'm going to plot my first one, which was at 2, 1. My next point was at 3, 3. And then my last one was at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And since it's even, remember this is my end point. So then I draw a curve through those points. Now let's try this just one more time, same equation, but with an odd root. So this is going to be odd, which means it's going to make an S shape. So again, what's going to make this equal 0 is the same as the other one, 2. But for odd, remember odds have a middle point. So whatever makes the radical equal 0, that's this point in the middle. So I like to put it in the middle of my chart so I remember that it's the middle. So it's going to be 2. I have 2 cube root 2 minus 2 plus 1. 2 minus 2 is 0. The cube root of 0 is 0. 0 times 2 is 0. And 0 plus 1 is 1. And then I'm trying to pick perfect cube roots. So I'm going to pick 1 and 3. And here's why. So if I plug that in, I'm going to get 1 minus 2 plus 1. 1 minus 2 is negative 1. The cube root of negative 1 is negative 1. So it becomes 2 times negative 1 plus 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Then I plug in 3. So it's 2 times the cube root of 3 minus 2 plus 1. 3 minus 2 is 1. The cube root of 1 is 1. Pull that 2 through. 2 times 1 is 2, and 2 plus 1 is 3. So then I'm going to plot those points, 1, negative 1, 2, 1, and 3, 3. So I go 1, -1, 2, 1, 3, 3. And since this is odd, that's my S shape. So my S shape kind of levels out something like that. So that's a good sketch of what it potentially looked like. So we've done harder problems and we've seen what AH and K can do to the problem. So we are done with graphing radicals. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.